Like I mentioned, CAD does have most of these in it for you, but you might have to end up drawing them to boot. I'm going to drop back a page. This one just shows a bunch of different symbols and how they're applied due to what we're trying. Notice it's on the bottom, it's on the arrow side, top, the opposite side, both sides, all around the field. Make sure you turn it all liquid. We're going to apply some backer to it. Need to grind it off flush, whatever the case might be. Here's some extra things that we can add to it. Again, like I told you, these can get fairly complex. Let's look at some of these welds now. 1194.
Can I ask a question?
Uh-huh.
Convex and concave, I mean, is that like a fillet and round? I mean, why would you specify those two?
Let's say you're welding these two things. Okay. And what we want is we've got something sliding across here, maybe going both ways. Wouldn't I really want my weld to be down here, underneath?
So it doesn't bump?
Yeah.
Okay.
If I wanted to get it flush, because really, I'd probably weld it, and there's probably a little bit of weldment right here, and I might have to grind it off, or something like that once it's done.
So we
Got to
do,
finish the weld.
so you put that concave thing somewhere
Mhm.
on
Yeah.
that? Okay. But wouldn't a normal weld be convex? Why would you have to specify that? Wouldn't a normal weld have a wood?
It has to do with finishing of it.
Okay.
Yeah. I can't give you a specific example. I'm sure we could find some, if we looked around here on some of our metal items, we would see most of these situations. All right, first one's a fillet weld. If you don't know what these are, here they are. So here they show you the size. Give you some nice examples. The author's got some good examples. By the way, your architectural book has a welding section in it also, if you wish to use it as another reference. I mean, it's pretty good also. So here, notice the leader's pointing to the joint. Okay, we've got a lap situation. We're going to fillet weld this. The arrow's pointing on the to the bottom. We're welding this side. Here's your result. Okay. Double-sided on the bottom example. Here's your result. This is a T situation.
On the fillet, does that have to be ground down a little bit?
Sometimes, sometimes not. I mean, if we can leave it without having to do any time, we're making it cheaper, right? If somebody's not coming in and trying to fix that up.
Does it have to do with how proficient you are at welding?
Yeah, just a little bit.
So if you're able to go along and you spread the proper amount of material, then you don't have to really go back and do anything.
Yeah, you gotta have a steady hand, you gotta be moving at the same rate, you can't have fluctuations in your power supply. And ultimately, when you do some of this stuff, when you get into the real technical things, some of it's out of your hands, and that's why we do it with machines. I mean, you gotta control temperature, you gotta do a lot of different things to this stuff. Because keep in mind, what does metal do when you heat it up? What does almost anything do when you heat it up?
Spin.
It expands, right? Same stuff. I mean, we do have a lot of welds. I saw one situation in a container once where it took them 3 days to do one weld. I mean, it was a big weld, but they couldn't get the thing very hot because it would have ruined the metal. And so they just have to do a tiny bit, walk away for an hour, come back, do a tiny bit more. It took them forever.
So there's a situation you may heat it, put on, then it cools and cracks it? Or
Yeah.
doesn't?
Yeah, you're heat treating that metal, right? Yeah, like I said, it's a very technical trade. So that's the fillet. Now the second most, these first two actually, the bevel and the fillet, are the ones primarily that I see most out there. So when I say a bevel, I kind of get that confused with a groove because it's a bevel groove, but there's a lot of different types of groove. So a groove weld. You've got all these different types of symbols for grooves, and they basically are just the different situations that we want. Typically, these are going to be a butt situation or an edge situation. Okay, that's when we do it. Now, the welder is going to have to do a little fabrication. Like a real common one is a V-groove, okay, where we come in and we're putting two plates together. Well, if they're straight on the edges, we can't get a good melt through on the thing. And so what they'll do is they'll come in and we'll cut or chamfer the edges, slide them next to each other, and then weld it at that point. And it gives us access to the back side of the joint. And you can kind of see the different top. The V-groove, the bevel groove, I see a lot of those. The others I don't see so much. Sean, maybe you want to weigh in. Do you know any other examples of some of the others? Have you done those?
Not really, that pretty much covers it.
Yeah, that's kind of what I've seen out there.
Yeah. Not unless it's something kind of awkward that's out in the field. You're not gonna do, the only one you're probably ever gonna do in the shop is a V-groove or just a square.
Yeah, we gotta have our machinery to cut that stuff. But pay attention to those two. Now, this one's got kind of a bunch of information that goes with it. Let's look down the bottom of the page. And here is your symbol. Okay. So we're doing a bevel on this one, right? And that's the symbol. You look at this little cut right here where it comes and it's only one way. If it was both ways, then it would be the V. So we're doing a bevel. So you got the size information to the left of it. 1/4 inch. The root dimension, the 3/32, that's how close we're putting this stuff together. Okay. If you put it at 0, we're going to butt them right next to each other. And then you have the angle that we want to bevel the surface at. So this is that one back on the original where there's some information that sits off the symbol down below it or up above it.
1/4 is your weld diameter.
Size.
And then the 3/32 is how far apart you are. And 45, what is the 45 for?
The angle of the cut that we're putting on this part.
Oh, so you actually have to put a cut on
Yeah, this is going to go through a saw before the welder's going to run through a saw before they ever weld this. With the groove and the fillet, you can handle most situations. They give you more examples on the grooves all the way through page 1197 for the different types and where all the information goes. And I'm not going to really take the time to go over each one of them. When you folks look through this, did anybody have any questions?
Yeah, like this is nuts. Yeah. Kind of like, boom, boom, like that's it.
We're going to get you a little practice. Break you in. Let's go to 1198. Okay, we got a plug and a slot weld here, and these are for lap situations. It's a square symbol. Okay. So they show the symbol here and what they mean right over here. Okay. So in essence here, we don't really have access maybe to the sides, or we don't want to do those. We're going to come through the material. And so in essence, we're going to have to, again, kind of prep this thing. If we're going to do a slot, we've got to cut this open, right? So we're going to get a router or something, we're going to cut that opening and then weld it and fill it back up. This one's just being drilled open. Okay. And you can kind of see how it works, where we're coming in, we're going to make sure we weld or melt into that bottom piece. And in essence, we're providing a key so that thing won't move back and forth.
So you don't drill into the second piece?
You may. they could probably touch it and fill it back up. Remember, this weldment's gonna be stronger than the original material. Now, you could even drill all the way through them, put a little backer on there, and then fill it back up and cut your backer off. And you could do a lot of different things with that, if you had to.
And how does that note? I mean, is it just telling you the diameter of the hole to cut?
Yep, that's their size,
And A refers to,
any angle that you might have.
What is the omit hole? Okay, wait, question.
Mhm.
So that diameter symbol is telling you that it's a hole.
Yep, diameter of the hole.
But they don't give you a number, or do they give you the size, or you just know you drill a hole? I mean,
No, that is the size of your hole. If it's a slot, you've got to dimension this out. Okay. Now, we'll see this another, I think there's one on the next page too.
but you, okay, so would you put a
There's that-
number with that diameter symbol, or just say diameter?
There's other numbers that go with it, Lisa.
Yeah,
That's
Okay.
just a
Yeah, there's a
really-
number.
Yeah.
They'll say diameter
That's generic.
5/8
Okay,
or,
okay.
yes.
And then why does it say omit hole?
I'm not sure why it says.
You're gonna drill a hole, but then you omit it, and then.
Yeah, because it's a spot weld where you don't drill and it just goes through it. On this one, on a slot, you've got to cut that hole. I'm not sure.
maybe they just mean that you're not supposed to show the hole.
Oh, yeah, it might be, we don't show it, right? Because we show it in the finished condition. We don't show the weldment. Good call, Cheryl. I would bet that's probably what it says.
You just call it that, okay.
Yep, you just call it out.
Okay.
Seam welds. Seam welds are kind of a cool little deal. Most of the time, these are done with light or radio waves. We can actually reach into things and excite molecules inside of them by putting, now if we've taken, like say, this guy right here where they're welding right in this area. Okay. What would have to happen is we'd have to have some electrodes on both sides. They're shooting electricity through, they meet in there and create a hot spot, and it melts things inside. So in essence, we can shoot into some material. I know on some of our haul trucks we used to do that, and we could shoot into those things a good 6 inches. And then have them coming from different angles and meet in the middle, and it would melt that metal inside.
So when you're calling on a diameter of the weld, that has to do with whatever you're shooting it with. I mean, how big the, I mean.
Your
you're not-
tip and everything.
You're not putting stuff in, so you grab different,
Mhm.
so your power source, your energy source has different heads or something that you shoot?
Yep.
Okay.
And I'm sure they can move them around too. I don't know, I've never done one of these welds. I've just seen them after the fact.
So there's no welding material.
What's that?
There's no welding material.
No, this one, generally, we do not add stuff to this. Because we can't get to it. So this one's just got the circle. That's for the spot. Where do you see this one done a lot at? Does anybody know? What's that?
Cars.
Cars. Okay, generally thinner materials. I mentioned, we did some big stuff on our haul trucks, but generally what you're looking at here is thinner sheets that we don't have to have tons of power to get through. Surface welds. Okay. So basically, mimics the shape and the size of how far the weld you want it up. We do this one here primarily for wear plates. So things that are on very abrasive areas. The metal that's underlying, we don't want to replace that. We don't have to. So what we do is we'll come by and we'll weld, 3/16 or a 1/4 inch bead all the way across that surface. Over time it'll wear off. When it wears off and starts getting back down to the metal, we'll come back in and weld it back up again and just put a wear surface on this thing. Think of dozer blades, grater blades, piping, these types of things. I mentioned those haul trucks, all our beds, once a year, we're down through that. That's why I never went welding. Just watch those guys in there burning beads 50 feet long. No way, I'm not gonna go do that. Like every job, I'm sure there's parts that are not a lot of fun. For us, it's dimensioning. For a teacher, it's grading.
It's never ending, huh?
Yeah. So that's your surface weld. A lot of wear plate situations. With all the food processing we have around here, although we don't have real hard surfaces, that I'm sure there's a lot of surface welding that goes on around here. The next example at the bottom is just showing pitch and length and how that corresponds. So when we talked about that a little bit earlier, if you're a little confused on it, then there's a good example for you. All right, you got 2 pages at the end of this chapter. You have page 1203 and 1204. Like I said, we're not welders. We're not the professionals here. We don't want to, unless you somehow bring that skill to the table, what you need to be able to do is to draw the assembly drawing and apply the technique that we're assembling it with, in essence, a weld note. These 2 cheat sheets, this one on 1203 and the next one on 1204, give you everything you need to properly place a weld note. They even go so far, they even got your 5 situations on here. You got all your symbols on the first page with the reference line, where all that information goes. You have your surface finish marks right in here. If you turn the page, here you have all of the dimensional information that goes on these. So if I'm doing a slot weld, okay, I just come right to here, look at this and say, oh, there's where I got to put my size, there's where I got to put my angle, this is what I've got to do. Just a word of advice when I say study these sheets. If for no other reason, then it will help your grade. Because when you take a test, I'm going to give you these 2 sheets
Without the information.
and ask you to apply it or read it. I don't expect you to remember everything you need to do with a J bevel. Okay, I don't. But I expect you to be able to jump onto this sheet and dissect that information and know what it's talking about. Those of you that took trig from me, the exact same thing, right? Know how to do these cheat sheets. We've got in our business just too much information to put in our mind. We try and put a lot of it in there. But well, you guys will find this out when you hit the workforce. You're going to have cheat sheets all around you. They're stuffed in your drawers, or you will have. Know these 2 pages. In essence, practice with them. Just jump into that book, open that up, go to that very first drawing, say, there it is, what's that telling me? Jump to here, see if you can see, match it up and see what it's saying. All right, that's kind of the whole chapter. So welding, let's kind of hit the highlights. It's a permanent fastener, right? It is meant that you must destroy the fastening method to get the thing back apart. Your drawings are assemblies in a multi-view format, as a general rule. You apply your weld notes accordingly, and that's pretty much the end of the story. Any questions on those? Oh, it's not bad. It's not bad. All right, let's take about a 7-8 minute break. We'll pick back up at a quarter after the hour. And I want to go over an assignment, and I also want to show you in CAD where a bunch of this stuff is already done for you, and you can just apply it.